Number one, which of the following powers is a perfect cube? Now, remember, this is a non-calculator question. You should be able to do this in like 25 seconds or so, okay? I know some of you thought, okay, 3 squared, that's 9, and then you're trying to do 5 to the power of 6, and you're multiplying it out. Don't do that. That takes too much time. Let me ask you to rewrite this like this. 3 squared is just 3 times 3, right? How would I write 5 to the power of 6? 5 times 5 times 5 times 5 times 5 times 5. Right, so there's 6 of them. How about 6 to the power of 4? 4 sixes. Okay, and then 9 squared is just 9 times 9. Now, when I say... Right. Sorry. Yeah. Hee. Now, what do I mean when I say a perfect cubed? What's that give you?
3.
3, right?
Groups of 3.
Groups of 3, right. Do you see a group of 3 here? No. Do you see a group of 3 here? No. How about here? Nope. Group of 3, nothing left over. Guess what? The answer is B. That's all you need to do, right? Perfect cube, right? Think about a cube and think about when you're trying to volume of a cube. The sides have to be the same. So same. Groups of 3. Okay? Now, let's take a look at number 2. 2 is a little bit trickier, okay? I must admit. This is kind of tricky. Okay, first of all, the bases are not the same. Okay, if the base was the same, if I had something like 4 to the power of 5, 4 to the power of 2, what's the answer here? What would you be? 4 to the power of 3. Yeah, you subtract the exponents. Easy. However, this one, not so easy. Because guess what? The bases are not the same. So the trick for this one here is, can you rewrite the 12 cubed? Okay? Using a number that perhaps is the same as the base in the denominator. So let's think about it. What times what gives you 12? 3 times what? So let me suggest us rewrite this as 3 times 4, and please write this down now, to the power of 3, all over 4 to the power of 3. Okay. Now, let's go ahead and use your ideas of exponents. Does anyone remember what we do when we have an exponent with two things multiplied to each other? What can we do with this exponent? Expand, meaning take the exponent on the 3, so 3 to the power of 3, yeah, and then also raise the number 4 to the same exponent. Okay, so you're distributing the exponent amongst the two things inside the bracket. That is great as well. Now you're thinking, how does this help me out? Remember, no calculator right now, right? No calculator. How can this help us out? I see someone doing this. Yes, what does that mean? Cancel out what? That's right. Those just divide out evenly. So what do you have left over? 3 to the power of 3, and oh look, the answer is B. Okay? So don't freak out about these non-calculator questions. They might look messy at first, but if you're doing it right, you don't really need a calculator to do these types of questions. Okay? Say that again, Suman. Oh, so here's another way, yes. Here's another way of doing it. Suleiman said, hey, Mr. Lee, the exponents are the same, so can I just combine it together as 12 over 4 to the cube? Is that what you're saying, Suleiman? Yeah, you're right. That works too, because what's 12 divided by 4? 3. What's 3 cubed? Well, that's the same answer here. That works too. Okay. Both ways work. Okay, number 3. Remember my ideas of flower power and all that kind of stuff for exponents? No? Oh no. Okay, so as a quick exponent review, maybe I'll write this down on the side. And this is chapter 4, by the way, exponents. Okay, there's a few properties you must, I guess, kind of know. The simple ones we've done before, but I guess I'll write them again. If I have something like x to the power of a times x to the power of b, what do we do with the exponents? AB, multiply? Add them. Yeah, you add them. When the base is the same, you add them together, okay? And then I heard someone say subtract, so what's the subtraction one for? Dividing by, yeah. So that's where you subtract, okay? I hope this is a good review. This is actually from grade 9, I think. And then what happens if I have an exponent raised to another exponent? AB, multiply, right. Okay. Let's do a few more interesting things. What about this? What if I had something to the power of 0? Yeah, that's defined to be just the number 1, okay? Anything to the power of 0 is 1. Okay, now we get into some more nasty things. How about if I wrote something like this, x to the power of negative n? So when we have negative exponents, and if I want to write them as positive exponents, what happens here with these numbers? It's the flip part where you do the reciprocal. So it becomes 1 over x to the power of positive n. Good. Okay. And then there's one more I'll show you, and this is my favorite. We have the nth root raised to the power of, let's say, m like this. When you have a root and an exponent, and if I asked you to write this as a fractional exponent, any ideas what the fraction could be? M over n. Yes, this is the one where I use that lovely idea of flower power, remember? The bottom number of the fraction is the root, so there's your n part. And then the top is like your flower, we call it the power, so therefore that's the power of m. So always m over n. Okay? Cool. Now, with this knowledge, you should be able to arrange this from least to greatest. My advice to you is to change all of these ugly roots into powers. Okay? So let's see if we can do the first one together. Any suggestions on root x as an exponent, what this number is going to be? What's the little root here when I say the square root? What number is like here, but it's not written down? It's like a 2. Good. And then there's supposedly a power here, but it's not written down. So what's the power going to be? 1. So what's the actual fraction going to be? 1 over 2. Awesome. Okay. So the first one here is just x to the power 1/2. I like it. Okay. How about the one in the middle? X to the power of what in this case? Take a guess. Something with a 3, yeah. 1 over 3, Oksana says. 1 over 3. Close. 1 over 3, that's what I wrote down. Negative, thank you. See the 1 over part? The 1 over, this is this one here that I'm going to highlight, right? 1 over. So therefore, you have to make this negative exponent. So thank you. X to the power of negative 1/3. Cool. And how about the last one then? 2 over 3, Anastasia says. Correct. Okay. So once you've written them all in exponential form with fractions like this, can you please now arrange them from smallest to biggest? Which one's the smallest? The red one, the green one, or the black one? Green one. So this is the lowest, so I guess that would be either A or B, right? C or D is no good anymore. What's the next one? What's the middle term between 1/2 and 2/3? Well, which one's the smallest there? It's the red one, 1/2. So that would be this one. So I believe the answer is just A. Okay. All right. I'll let you take a look now at numbers 4 and 5. Number 4 has something to do with the GCF and LCM stuff. Greatest common factor, lowest common multiple. So I'll let you think about that for a second. This one's kind of tricky too, okay? But this is chapter 3 tricky. And then number 5, you have to simplify cube roots. So that's chapter 4, okay? Not so tricky, I don't think. All right, I'll give you a few minutes to think about this first, and then we'll come back, all right? Okay, let's do number 4, please, together. What are they saying here? You've got 2 gears, and one of them has 6 teeth, and one of them has 8 teeth. And it says as gear 1 turns, so as one turns, the other one turns at a different rate. And it says gear 1 is rotated until the 2 gears are back to this starting point, meaning they both are at the same spot. Think about it. Both are at the same spot. One has 6 teeth, one has 8 teeth. What am I looking for if I'm saying we're going to do this a few times until they get back to the same spot? Am I looking for GCF or LCM? LCM, someone said. Yeah, so think about it. 6 teeth. If I rotate it once, I get 6 of them. And then if I rotate it twice, I get 12. 3 times 18, 24, and so on and so forth, right? Same thing with the gear number 2. If I rotate it once, I guess it goes around 8 teeth. Twice would be how many teeth? 16, and so on and so forth. And the key idea that I know this is LCM is because you want them to be in the same starting position. So you want them to rotate enough so that they're back in the same spot. Now, you can find LCM by listing out the multiples, or you can do something else. I remember this thing that I showed you, maybe the 6 and the 8. Remember this? That little L bracket thing. So if you want to do this to find the lowest common multiple, you can as well. Remember, how do we do this? Anyone get an idea for me? 2. Yeah, so you're looking for what number divides evenly into both 6 and 8. So someone suggested 2. We'll do that then. Take the 2 and I put it out in front. Then we do 6 divided by 2 is 3. 8 divided by 2 is 4. And then you ask yourself, can you still find a number that divides into 3 and 4? No way. So your LCM is just all these things put together. So your LCM means 2 times 3 times 4, which is 24. Okay. By the way, how would I find my GCF looking at this L bracket thing as well? No, not 3 times 4. The LGCM is just, the GCF is just the numbers on the left side. So in this case, it's just 2. Okay. Okay, so you're thinking 24. Does that mean it's 24 rotations? No. Okay. 24 is just the number of teeth, right? It moves around. Now let me ask you. It says, what is the minimum number of rotations gear 1 requires? Okay, so we're looking at gear 1 to return to this starting position. You're saying that the starting position means that each of the gears should turn 24 times, or 24 teeth. 24 divided by what? Nice. So Yelena says, take the number of teeth, 24, divide it by the number of teeth in gear 1, which is 6, and that tells you how many rotations. Correct. So this one was a little bit tricky because most people will choose 24, but the actual answer is C, 4 rotations. Okay. By the way, if I said gear 2 requires how many rotations, how many would there be? Yes? The answer key says B? What answer key? No, that's a different answer key for the one in the back. That's for the chapter 4 booklet. I didn't give you the answers for these ones yet, okay, Patrick? So the ones I'm doing right now with you, I don't give you the answers yet. I have them myself, okay? So don't look in the back and say, oh, I have the answers. Not yet. You don't have the answers for this booklet yet, this first 2 pages. Okay? The answers in the booklet represent the last part, the chapter 4 review. Okay? Sorry about that. Okay, try number 5 here, please. Okay, so you have questions like this too on the provincial exam where, you know what, they'll show you all the work and then you just have to tell me which one's the mistake. It's like you pretend to be the teacher. Figure out who's the person that got it right and got it wrong. Yes, Susanna. Go. So let me ask you to look at these, please. You've got 3 students. The question that the teacher gave them is, what's the cube root of 1080? And this is already the correct answer. Okay, they already told you this is the correct answer. But you're looking at the student's work, and you have to decide which student actually did this right and got the right answer in the end. Okay, so I'll give you a chance to look at this one first, and then please move on to number 6, 7, 8, and 9. Okay, how about 2 minutes here? Do you guys remember how to simplify these roots? There were 2 ways that I showed you, and the students actually did 2 ways, okay? One way is to just rewrite them as, so rewrite using prime factors, okay? And I think that's what Jean was trying to do, okay? The other method is to rewrite, okay, as multiplication. And in this case, because it's cube root, you're going to do the multiplications of cubes. Okay? So you're thinking, what's the largest cube, or what they call perfect cube, okay, that divides evenly into that number 1080. So there are 2 methods that I showed you, and I said to you, hey, you know what? You choose whichever method you like best. Okay? If you were to double check this, you don't have to do it yourself, but you can just bring out your calculator. And especially for Jean, what I think Jean was saying is, hey, 1080 is equal to all these things multiplied together. Okay, so let's double check if that's correct first of all for Jean. 2 times 2 times 2 times 3 times 3 times 3 times 5. Is that 180? Yeah, so at least her first step here is correct, okay? We know that Jean's first step is correct, okay? Now, we can continue on looking at Jean's, and we can look at Sally's stuff. It's up to you. Okay. Just look at genes? Okay. So now what's this next thing that she did? Remember when you have cube roots, what I tell you to do? Look for groups of 3. So here's a group of 3. Here's a group of 3. That's cool. And what do you do when you have groups of 3? Take them to the front. And then I think that's what she did here, 2 and a 3. Is that okay? What's wrong? Oh, this should be a multiplication. Right. Oops, Jean, you messed up. Okay. Oops. Even though in the end her answer is right, her work was wrong. So guess what? Which student made a mistake? Okay, we know Jean made a mistake. Okay, so for sure Jean. Now let's move on to Sally and Mark because it has all of them could. Actually, you know what? You're done for this one already. You know that the answer is A. But let's just double check about Sally and Mark, okay? Sally says, hey, the 1080 is 216 times 5. So let's double check if that's correct. You can use your calculator, multiply 216 times 5, and look at that. It's 1080, so at least we know that's correct. Then what do you think Sally did? Well, in this case, Sally looked at the cube root of 216. So what number multiplied by itself is 216? And of course, you can use your calculator for this one. So you can just use the cube root of 216. And the number was, oh, it's 6. So that part's okay. And then, of course, that just means this whole part here is 6. And you're left with a cube root of 5. So Sally is correct. Okay. How about Mark? Did he did it right? 1080. Is that 27 times 5 times 8? So let's double check that if you can. Okay. 27 times 5 times 8. That looks to me like it's 1080. So that first line is correct. And then I think Mark just split this up and looked at the cube root of 27. And he also looked at the cube root of 8. So is the cube root of 27 3? I believe so. The cube root of 8 2? I believe so. 3 times 2 is 6. I believe so. Sally and Mark are correct. So the answer is A. Okay. Any questions?
Wait, the cube root of 216 is 6.
Yes.
And then you take the 5 and you just have the cube root of 5.
That's right. That's what's
And
left
then
over.
6 and then cube root of.
Yeah, that's what's left over.
Okay.
Yeah. Okay, let's move on.
Yeah.
Shall I do these with you together, or shall I give you some time to work on them? Just do them together?
Yeah.
Okay, let's do that together then. Number 6. This one's kind of nasty too. I hated these ones. Okay. All right. Oh, joy. So much stuff. May I ask you, if you can, always try to simplify the bracket first. Okay? Simplify the stuff inside the bracket first, if you can. It makes life much easier. Okay? Remember when we're doing these? Numbers separately, exponents separately. So let's take a look. 54 and 2, those are my numbers. What's negative 54 divided by 2 simplified? 27. Positive or negative? Negative. Okay, so negative 27. Good. Okay. The next part, x to the power of 6 divided by x to the power of negative 3. Yeah, remember when you're dividing, what do we do with the exponents? We subtract. So what's 6 take away negative 3? 9. Okay. How about the y's now? So notice there's no exponent on the top one. We just call it the power of 1. So 1 take away 4 gives us negative 3. Good. So this is what we got so far. Okay. All raised to the power of 4/3. That looks much nicer, even though you might not think so. It is. Okay. Now, I think now is the time where we want to now distribute that fractional exponent. Okay. So remember when we have something like this, multiplication, 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 we can distribute the exponent into all these terms. So this is what I mean. Negative 27 to the power of 4/3. We'll take x to the power 9 raised to the 4/3. We'll take y to the negative 3 raised to the 4/3. Okay? We'll do them individually, and then we'll put them all together, and we'll get our final answer. Okay? All right. This first one. Fractional exponent, number. Can you think of the flower and the power? So what does that 3 represent? That 3 is the cube root. Good. So what I'm asking you to do now is take the cube root of negative 27 and then raise it to the power of 4. Okay. So think about that, please, while you work on that. What is the cube root of negative 27? What's that, first of all? Cube root of negative 27? Negative, not 9, negative, no. What times what gives you 27? No. Negative 3. You can use your calculator, by the way, if you're not too sure, right? You can use calculator for this one. Okay.
Life is so hard without calculator.
Okay, now raise this to the power of 4. Mehdi, what's up? Yes. Y is x to the power of 9. 6 minus negative 3 is 9. You see here, x to the power of 6, x to the power of negative 3. When you're dividing, you subtract. Okay. So what's negative 3 to the power of 4? 81. Good. So automatically, and this is the nice thing about multiple choice usually, you can already get rid of 2 answers right away. Right? Now it's going to be either C or D. Well, let's take a look at which one's going to be. Let's do the next part now. Okay, let's do the x's. X to the power of 9 to the 4/3. Now, we don't have to rewrite this as a square root and all that kind of stuff. Because what do we know about exponents? Exponents next to exponents. What do we do with the exponents? Multiply. Exactly. So here, I'd just like you to multiply the exponents. What's 9 times 4/3? 12. So I think you already know which one's the answer, but let's just finish this off. Okay. With the y's, we'll do the same thing. We'll multiply the exponents. What's negative 3 times 4/3? Negative 4. Good. So this whole thing is your answer. And remember, most people don't like being negative, so they don't want negative exponents. How can I rewrite this using positive exponents? Well, 81. Yep. Yep. Thank you, Paula. So the y to the negative 4, we can bring it into the bottom and then change the exponent from a negative to a positive. D. Okay. All right, number 7. Time to do some algebra. Chapter 3. Okay. Oh my gosh. It's okay. Lots of stuff to do, I know. Lots of stuff to remember, but that's why I give you this stuff and you can practice, okay? I mean, I'm not asking you to do it all tonight, but you've got a week and a half to try it as much as you can, okay? The more you do, the better you'll get. Seriously, even if you get them wrong, but the more you do, the better you'll get. Okay, number 7. You know what? I've seen this so many times. This thing called lateral surface. What does lateral mean? Just the sides, right? So lateral just means the sides. So no top in this case, also no bottom. Okay? And I guess they gave you a hint. They shaded in the sides for you. Okay? Too kind. Okay, so it says find the surface area of the prism below, at least the sides of the surface area, prism. I guess that means you need to find the area of all these shapes. Interesting. What kind of shape is this? A rectangle. Good. How do you find the area of a rectangle? Length times width. So the area of this one will be length. I guess that's 2x plus 1 times the width, which is x plus 2. Remember seeing stuff like this with 2 brackets? So how can I simplify by getting rid of these 2 brackets? Expand. Thank you, Suleiman. Let's expand. We'll do this together. 2x times x gives us 2x squared. Good. 2x times 2 gives us 4x. Okay. You need a calculator for that? No. Kind of. All right. 1 times x. 1 times x. It's just an x. And then 1 times 2 is 2. Now, can we simplify this before we do even more? Yeah. So let's combine all like terms here. 4x, 1x, that's 5x. 2x squared plus 5x plus 2. Okay, that's the area of this piece that I'm going to shade in red. Cool. But that's not my answer, is it? What else do I need to do? The other side. Right, so let's use blue. So let's find the area of this side. What shape is this, by the way? It's also a rectangle, so it's the length times width. Is it the same thing? I don't know. It looks like this is 2x minus 1. Uh-oh. Okay, 2x minus 1. And then what's the height of that? X plus 2. Okay, so you do this, please, now on your own. Let's see if you can multiply this out. Okay, so you're doing your algebra, I'm doing mine, and I've got an answer for the blue part already. 2x squared plus 3x minus 2.
Yeah.
Agree, disagree?
Yeah.
Agree? Okay. Now what? Add them together, sure, because I want those two sides. So let's add them together. This plus this. Let's add them together. So if we add them together, let's take a look. 2x squared plus 2x squared is how many x squareds? 4x squared. It's good. 5x plus 3x is 8x. 2 minus 2. 0. Okay. Are we done? That times 2. Why do we now need to take my answer in green multiplied by 2? Yeah, there's two other sides behind it too, right? The two sides behind it. So let's double it. Okay, and then now I think we'll be done. What's 2 times 4x squared? 8x squared. 2 times 8x? 16x. Which one do you choose? A. A, okay. Woohoo. Nice. Okay. Like I said, these are quite involved questions. A lot of the questions on here are the more trickier ones, okay? So I'm hoping to do the tricky ones with you so that when you do your review, you can just do the easy ones and feel good when you get home. Okay. Check the next one, which is kind of weird too. Okay. All right. This one's weird, but let me try to give you a hint. The question says determine an expression for the area of the largest square. Okay, point to the square that's the largest. Top, middle, side, which one is it? Yeah, this one's the largest one, right? Right here. Cool. Notice that the side length of the square seems to be the slanted part of a right triangle. Maybe this right triangle will help me find the area of that large square. Remember seeing a picture like this in grade 8? When did we use this picture in grade 8? We're talking about what crazy guy's formula? I mean, not crazy guy. Yeah, Pythagoras, right? Like a squared plus b squared equals to c squared. That's the visual representation of Pythagoras, okay? Right? You see that? A squared, the smaller square on the right, or the left, sorry. B squared, the smaller square on the bottom. You add them together, that gives you c squared. Well, do we know what a and b are then?
Yeah.
Because if we know a and b, then we can find c squared. Because ultimately, the largest square is just equal to c squared. So can someone help me out then with the formula? A squared plus b squared equals c squared. The c squared is what I want. So what's a first of all? What's the measurement for a? Yeah, it's x plus 1. Excellent. And we're going to square it like that. Okay? And then what's b? 2x minus 5. Yeah. And we're going to square that. And then that just equals to c squared, which is great because c squared is the area of the largest square, which is what I really want. Okay. So there you have it, dear friends. If you can just go ahead and expand the x plus 1 all squared plus the 2x minus 5 all squared and then add them together, we're done. Now, when you're thinking about squaring, how many of you are thinking this? I will square the x, I will square the 1, I will square the 2x, 4x squared, I'll square the 5. How many thought that? Be honest. No one? Good. Because if you did that, you'd break my heart and kill me. What do we have to do? Yeah, distribute. See, remember the square means you multiply by itself. So when you write it like this, everyone knows now, oh yeah, distribute in FOIL, and life is good. Okay, when you try to like do it without it, you will kill your math teacher. X squared plus 2x plus 1. Okay, I'm going to ask you now to do the same thing on this side here. So that's 2x minus 5 times 2x minus 5. Remember, you don't want to give your math teacher a heart attack. Why not? Because you like him. And you want him to teach you again next year. Okay, some of you might not. Okay, so keep going, please. What's 2x times 2x, by the way? You don't have to whisper, but 4x squared is correct. Yeah, okay. 2x times negative 5, negative 10x. Negative 5 times 2x, another negative 10x. And then negative 5 times negative 5 is 25. Okay. And then just collect like terms. Lots of multiplication. Now we're going to add. X squared, how many do I have there? How about 5? 2x, uh-oh, minus 10, minus 10, uh-oh. That's negative 20 plus 2. Can someone say negative 18x? And then we've got 1 with 25. We'll put those like terms together. What's 1 plus 25? 26. And this equals to the area of the largest square. So I think we're done. Right? That's what you're looking to do. That's the area. Because remember, this is c squared, right? A squared plus b squared equals c squared. So I didn't ask you for the one side. I just asked you for c squared, the area. So I think that's all you have to do. You're done. D. Good. Okay. All right, let's see if we can get through all of these. We're rolling, rolling, rolling. Number 9. See, here's one of those mistake questions again. Okay, they asked you to find the person's mistake. Now, this is a kind of weird way of writing what people will do, but let me just show you what they mean. You see this x here? That means they are multiplying the x by each of these terms. So this is what they're doing here. X times 2x squared. That's this first part. Okay? And then x times 5x. That's this part. Do you see what this table or chart looks like now? And then x times negative 8. That's this part. Okay, then get the answers here. Does that make sense? You see what they're doing?
Yes.
Okay. And then I guess the negative 3, they're going negative 3 times 2. So that's this number. Negative 3 times 5, that's this one. Negative 3 times negative 8, that's this one. Okay, so they actually want you to do all of them. And then they want you to tell me where's Derek's mistake. Is it in step 1, step 2, step 3, or step 4? Okay? So you choose the answer then, okay? So I guess you can just double check if you want. Okay, I'll do the purple one together first. What's x times 2x squared? Is that 2x cubed? I think so. Okay. How about the next one? X times 5x. What's that? That's 5x squared. That's correct too. Okay. X times negative 8. Is that negative 8x? That's correct too. Okay. So we'll do the ones over here now. Negative 3 times 2x squared. That's negative 6x. Negative 3 times positive 5x. Negative 15x. Negative 3 times negative 8 is? Positive 24. There you go. Step 3. You're done. Okay. That's it. All right, let you try 10 and 11 and 12. Out of the next ones, I'll tell you that 11 is the trickiest of them all. So I'll do that one with you for sure. But you should be able to do 10 and 12. Okay? So I'll give you a few minutes just to try this right now, because I don't want you to listen to me all the time. And I'll come back in about 2 minutes, okay? Okay. How do you factor number 10? What's the first step here, dear friends? What do you see here? I see 5. Can you see that both of these numbers are divisible by 5? So factor out the 5 first, okay? So when factoring, I'll say always factor out the GCF first. always factor GCF first, the greatest common factor. Okay? Then you have choice depending on what you see. Okay? Ladies, you with me? Okay. Now, in this case, can you see, by the way, what did I do wrong? Thank you. Just trying to be a regular math 10 student who makes these mistakes. Don't forget, 20 divided by 5 is 4. Good. Okay. Now, once you get to this step, you have a few choices. If you see it's a difference of squares, and that means you have two terms, then remember you have like a plus b, a minus b. Okay. Otherwise, you have to what I call factor the trinomial. Trinomial means then there are three terms, and I'll show you that one in a second, like number 12. Okay? So you have to decide what it looks like, and then based on that, figure out what type of factoring it's going to be. Okay? So in this case, is it a trinomial or difference of squares? Tell me that first of all. Difference of squares, yeah. Hopefully you see x squared, and then 4, which is what squared? What squared is it 4? What number squared is equal to 4? 2. So can someone suggest to me how I can factor this stuff now? What will this be? X minus 2, x plus 2. Now don't forget you still have a 5 in the front. Okay? So there it is. There's factored form. But the question didn't say what's the answer. It's telling me how many factors are there. So how many factors are here? I see a factor. I see another factor. I see a third factor. How many do we have? 3. Okay? So each of the brackets is a factor. Even the number in front is also a factor. Okay? Okay, 11, tricky. I got 10 minutes. Let's see if I can do all this stuff really quickly for you. Okay? 11, one of the factors is this. The other one is that. Okay, what's going on? What they're saying here is 3x squared minus 16x plus k. If I factor it, one of the factors is x minus 7, and the other factor, I don't know. And I don't know this, but you're supposed to find out k. Whoa. How can we do that? Now, usually there are two terms. Okay? One term, two terms. Remember how we usually do this when we multiply? We take like the x and we multiply by the first term, and that gives us the 3x squared. So just as a quick thing, what do you think this missing part here is going to be? X times what gives you 3x squared? 3x, I heard. Awesome. Good. Now this other number here, I don't know. So something you don't know, what do we use in math usually? N? Sure, we'll call it n. Don't use x because we already have an x. Let's use the n. Okay, good. Now, you're thinking, Mr. Lee, there's so many variables I know, but hopefully you can, do something and get some ideas. So let me ask you now to multiply this out. What's x times 3x again? Oh, sorry, x times 3x, I said. Okay. Now what about the next one? What's x times n? That's just nx. Okay. What's negative 7 times 3x? Minus 21x. Yeah, and what's negative 7 times n? Negative 7n. Okay. You're thinking, Mr. Lee, this still looks pretty ugly. Oh, I know. Okay. Can you see these two terms in the middle? You see how they both have x? See that? So they're like terms. We can combine them together. Meaning this, n take away 21 times x. Okay, I can factor up the x and I have n minus 21. Now, how is this supposed to help me out too? You might be asking. Can you see how this number here, the n minus 21, is the number in front of the x? What's the number in front of the x? In green over here on the left side. 16. So what I want you to do is compare. You see, we have 3x squared, we have 3x squared. That's good. The negative 16 should be equal to the n minus 21. Right. So from here, if we were to compare, and I'll say compare, we now know that n minus 21 equals to negative 16. Can you help me solve for n, please? 5 it is. Patrick says n is 5. So Patrick, how is that going to help me out in terms of finding out what k is going to be then? What's k equal to? K is equal to what over here in red? Compare the red with the green. Is it the what? Yes, this part. Can you see how these are the same? I'm going to try to like highlight them. See, same. That's the yellow part. Here's the green part. Can you see how they're the same? Green, red, triangles, right? See? Right, so k just equals to negative 7n, okay? So therefore what we're saying here is k equals to negative 7n. So what's k equal to? Negative 7 times 5. What's negative 7 times 5? A. Done. Okay? All right, let's do 12, and then I'll do one of the 13s. Maybe I'll skip 14, and then I'll do one of the ones at the end. Okay, do you remember how to factor this, dear friends? Remember how to factor? This is the one with the trinomial. You're looking for two numbers that multiply to the last term, which is 6. Those same two numbers have to add to the middle term, which is negative 7. So what must those numbers be? That's what they're asking you here. Any suggestions? Two numbers multiply to 6, minus 6, and 1? Positive 1 or negative 1? Positive 1. Negative 1. Negative 1, yes. Negative times negative gives you positive. So really what you've done for me now is you factored this. That's great. But then, oh, wait a minute. This question didn't ask me to find the factors. This question has all this weird stuff of all this gibberish. Uh-oh. Okay, well, what are they saying here? X plus A, X plus B. Well, I factored this into X minus 6, X minus 1. So if you were to compare these things, what is my value of A? In this case, A is negative 6. In this case, B is, I guess, negative 1. So my question now is, knowing that A is negative 6, B is negative 1, can you tell me which one of these things, 1, 2, 3, 4, 5, is true? So I guess we have to go down the list and figure it out. Okay? So let's take a look at number 1. Is A times B negative 7? Is negative 6 times negative 1 negative 7? No way. Forget that one then. Okay? How about number 2? Is A times B equal to 6? Is negative 6 times negative 1 equals 6? Oh yeah. Okay, let's double check the other one. Is A plus B, so is negative 6 plus negative 1 negative 7? Yeah. Okay, so 2 looks good. Ding, ding, ding. Okay. Let's try 3. Is A bigger than 0? No. Strike out. Okay. How about number 4? Is A less than 0? Yep. Is B less than 0? Yep. Ding, ding, ding. Okay. 4 works. And how about the last one? Is A bigger than 0? No, we've been through that already. So guess what? The only statements that are true are 2 and 4. So you choose number, or you choose C. Awesome. Okay, I've got 5 minutes. Let me just quickly do 2 more questions for you, okay? And I'll let you try the rest on your own. Whew. Hey, remember these math tile things? No, you don't remember these math tile things? Which one's this? Remember how we did this like this, and then we would put tiles up front here? Yeah. Now my question to you is, if I were to draw this, and please draw this in yourself too, okay? Do you remember how like the white ones were positive, I think, and the dark ones were negative? Yeah. Yeah. Now, I guess my question to you is, it says, which of the following areas formed by math tiles are factorable? Meaning you can factor this into lovely things. Okay? You can write them as how many up here, how many down here. Okay? Now remember, there are some properties that we need to understand. What's wrong with A, by the way? You see here, these are dark, and then these are light. Can't have that like that. Okay? This is like having a negative 1, and a plus 1. We don't do stuff like that. These have to be the same color. So forget it. This is a problem. Okay? Let me take a look at B with you. Okay? At least these groups are the same colors, right? Dark, light, 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 light. Okay? But let's think about what this means. Okay. If they are dark, okay, if these two big squares are dark, that means they're negative. That means one of these pieces must be negative, correct? So for example, if I kept this one as positive, then this one has to be negative. Okay? And then because these are light, I guess these have to be positive as well, so I have to keep them as white. So positive times positive gives you positive. Okay? Positive times negative gives you negative. Okay. Now is this one okay? Because let's see what happens over here. What should these little squares be? Light or dark? These little squares here. I'm thinking these are light as well. That should be white. Okay, let's think about this though. If this is white times a dark, or a positive times a negative, what should these be? They should be negative, so oops, this one doesn't work either. Okay? So I'm going to ask you to think about this, and I'll let you try. Which one is the correct one, C or D? Okay? Let's move on, because I don't have much time. Let's move on. I'll give you the answers afterwards. Okay, this is the same idea, determine the missing label, so I want you to just tell me what is W, so think, okay, and then, are they light or dark? Okay, you decide. Okay, can we just flip to the last one here, number 16, really quickly? Okay, so here's number 16. It says, when you got the 4th root of 7 to the power 9, and you've got the 5th root of 7 to the power 3, and I want you to simplify it to 7 to the power of n. What's n? This is one of those written questions where you have those boxes, remember? Box, 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 decimal, box, box, with a plus or minus in front. Good question. Let's do this together, quickly. How do I change the first one into a fractional exponent? What's a fractional exponent? Remember flower power? Is it 4 over 9 or 9 over 4? Flower power, okay. The exponent on the top, the root on the bottom. How about 7 cubed and then the 5th root? Say that again? 3 or 5, good. What do we do when the bases are the same now? You multiply. What do you do with the exponents? Add them, right, add them. So here's what I'd like you to do. What's 9 quarters plus 3 fifths? Here's where you need to know how to do fractions, okay? How do you do fractions? How do you add fractions? Can you add them when the denominators are the same? Or different, sorry? No, you got to change them to make them the same. What's the common denominator between 4 and 5? 20, good. Let's do this really quickly together. So 9 fourths is equal to how many 20ths? 4 times what gives you 20? 5. 9 times 5 gives you? 45. How about the next one here? 5 times what gives you 20? 4. 3 times 4 gives us? 12. So what's 45 over 20 plus 12 over 20? 57 over 20. So if you want to know, this is the same thing as 7 to the power of 57 over 20. Okay? But what do they want you to figure out on the test? It says determine the value of n and answer to 2 decimal places. What is n here? It's the exponent, right? It's this thing. That's n. So use your calculator right now. 57 divided by 20. What do we get? 2.85. Correct. Okay. Positive, and you're done. All right, let me just give you the answers to 13, 14, 15 before you go, and then you have to do a lot of studying. Okay, once again, for those of you who want to write the end of term test, that's next day. It's optional. You don't have to do it. If you do poorly, I don't care. I won't count it. And then please come back on Friday. I'll give you your final mark before we go to homeroom. And then I'll also tell you when I'm available next week on the 18th and 19th and on the 20th to help you study for your provincial exam.